Perfect. Okay. So what you want to do is you want to isolate the absolute value first. So what's inside the absolute value here?
2x plus 8.
That's got to be isolated. Right now, it's not isolated because what's connected to the absolute value?
5.
Move that -5 over first. You got to do that first. Yeah. The reason why is because you're trying to figure out what does that inside have to equal. That inside has to equal 16 or -16. Let's see, if you start splitting it right away, you're going to get a wrong answer. I've seen students do that because they memorize. They don't understand. You got to understand that I got to isolate the absolute value so I know what value it holds. Now we're ready to split. Yeah, Alexander, go ahead.
Why the negative component of the equation, but why is it 16? I understand that everything in absolute value comes out positive.
Right, correct.
16.
Because 2x plus 8 is going to equal 16, or 2x plus 8 could equal, sorry, 8, not 18, -16.
But wouldn't it be the components inside the absolute value?
Exactly. Yeah, it could be -16, of course. So this entire thing on the inside of the absolute value could be -16. Because if that's -16 on the inside, what's the outside -16? 16, and 16 minus 5 gets me 11.
Yeah.
So what you want to do is you want to move that 5 over first, then split. You have to isolate the absolute value first. You look confused. Okay. So let me back up a little bit here. Were you hoping to do this? By the way, what I'm doing right now is what you don't want to do.
No.
Were you hoping to do that? No? Okay, don't do that. Okay. Okay. Okay, yeah, go and tell me, yeah. Sure, please.
Like 2x plus 8 equals 16 or 2x minus 8.
Oh, good. Okay, I'm glad you brought that up. That's another mistake. Let me solve the problem first the way it's supposed to be solved. Yeah, it's PEMDAS, that's why. It's order of operations. Because so let me ask you this question. Like if I had 6 minus 4, right? That of course that's 2, right? What you're telling me is that we could switch it and it'd still be okay, but that'll be a much different number. It'll be 10. We can't do that because it's PEMDAS. The absolute value, so you have to treat the absolute value the same thing as parentheses. You got to take care of everything inside the parentheses first, then do the absolute value afterwards. That's why. So think of it as the parentheses inside. I know it's you want to do the absolute each of those individually. You cannot.
I know you have to treat it as one, but
yeah, exactly.
I know
that's why.
Okay.
That don't overthink it. Don't overanalyze it. Just treat it as one and make it one. That's all you got to do. So, okay, I'm glad we cleared that up. That's a good misconception that happens. Misconceptions are bad. Sorry. There's a common misconception that happens. But what you want to do is isolate that value and then solve it, which is pretty easy at this point, right? X equals 4, or 2x equals -24, x equals -12. So you get two answers, 4 and -12. And do check your work. I will advise you to check your work on the test. I'll say to actually check it.
How do you do that?
Plug it back in the original equation. You plug it back in and make sure it works.
But then what do you do with the brackets after you plug them in?
What do you mean by the brackets?
Like, absolute values.
Oh, yeah, you apply it. So if you plug 4 in, what do you have? You have the absolute 16 minus 5 equals 11, which is a true statement. That is true. That will work. Because what's the absolute 16? 16, right? 16 minus 5 is still 11.
And how do you do it with -12 someday?
If I do -12, so I do 2 times -12, which is -24. Sorry. And that becomes absolute -16, which is still 16. Okay. And then -5, you still get 11. So it's all good. All's good. Okay. Okay. Don't worry about number 2. You can cross that off. We're not asking that. Cross it off. So don't freak out. I'm not asking that on the test. We didn't cover that.
What?
Good. All right.
What?
Okay, number 3.
What?
Actually, let me come back to number 3. Let's do let's jump to 6. I'm gonna jump around a little bit. Yeah, go ahead. Yeah.
No.
Yes, you for number 2 you will, but not the actual graphing of inequalities. That's by hand. No, 3 will, because that's a different, that's not an inequality. 3 was just,
Oh, sorry. I
yeah.
didn't see it.
okay, I'm gonna jump to 6, just because I've already been solving equations. So you can see a problem like this as well. And this is also a problem I've seen students mess up. Okay, what should you do as your first step, guys?
Square.
No idea is not a good strategy.
Square.
Square both sides, yes. That sounds better. Yeah, square both sides. So you should get that right.
Minecraft word.
And then you get this. And then you solve. Perfect. Thank you, Eloise. Yes. So I know I did it kind of fast, just in interest of time, but yeah, you square both sides and factor it. Great. And give me the value of each. But you have to check your work, and I do even advise you to check your work. Extraneous means an answer that is deceptively true. That's deceptive. That it looks like it works because you did the algebra, but then when you throw it back into the equation.
You want us to do like the x equals 5, not just.
And why not? That's correct. Why not? Right. Yeah, the outside can't be negative. Exactly. That's very good. So exactly what Eloise said, right? So if you think about it, if I plug in 5, 5's cool, right? 4 times 5 plus 5 is root 25. Sorry, my handwriting's terrible. Is root 25. And guess what? That equals 5. So that's cool. 5's all good. -1's not cool. Exactly what Eloise said. If I plug in -1, I get -4 plus 5. Of course, that's going to be root 1, which is 1, right? But what are you going to get on this side then?
1.
-1, right? And those don't equal each other. So it's not going to work. Yeah, because you get root -4 plus 5 equals -1. That's not true. That can't work. Correct.
You need
Correct.
us to show it, or would it be
Yes,
5?
you have to show it. So the way I'm going to grade this problem, this is a 5. Most of the problems are 5 points, as I mentioned yesterday or 2 days ago. That'll be worth a point for squaring. For cleaning it up will be worth another point. For factoring will be worth another point. Solving each of these will probably be worth a half point. And another half point for checking. So I'll give another half
Like
point.
circling the right one and crossing out.
Correct.
Yeah.
Yeah, so that's how I'm going to divvy up the points. So if you don't check, you'll probably lose a point. If you factor in correctly, but everything else is done fine, then fine, maybe I take a point for the factoring correctly. Or if you somehow move things around, like I will tell you this, it's gonna factor. It doesn't factor, don't check your work. And guess what happens? Like, what if you actually put plus 4x? Yeah, you're human, that's fine. You're like, I can't factor it. Go back and double check your work, make sure you moved everything. That's what I'm saying, you can't be sloppy with your algebra. Algebra sloppiness can add up, so we gotta be very careful. Okay, so we're cool with that. And then we're gonna have this on Jeopardy game today. So in Jeopardy, we are gonna play for extra credit towards a major category. Tom massaging things. Okay, so but we'll get there in a moment. Yeah. No, you guys, we're gonna do teams of 4. You guys can, yeah, we'll figure out the teams, but don't worry about that. We'll figure out later. Sharka. A little bit, yeah, but some questions aren't applicable. Okay, let's now jump to another question. Equations again. Number 4. This is a review question. Because I did say this. We are going to have a rational equation. I did say this. And it is going to be worth 6 points. And it's going to kind of look like this. And it's going to be a little, I'm going to be honest, it's going to be a little nasty. I'm going to be honest. It's going to be, but the reason why, yeah, it's going to be a little nasty here. And the reason why is because, hold on. Am I looking at the right one? Hold on. This is number 4, right? Wait. Hold on. Oh wait. Do you guys have this as number 4?
Yeah.
Then wait, what am I looking at? Hold on. Why am I looking at something funny? Oh, never mind. My answer key's off. Never mind. We're good. We're cool. All right. Here we go. The answer key's off. The LCD. You want to find the LCD first. So look at how many fractions you got. 3. What's the denominator of the first fraction? That's part of your LCD. What's the denominator of the second fraction? That's part of your LCD. What's the denominator of the third fraction? It's part of it again. That's your LCD. That's how you build it. You have to take each part, right, and build an LCD that way. Now, this is the part where I'm going to be highly critical. I don't know how this is taught in middle school, like fractions, or what tutors do. I'm going to be incredibly egotistical and arrogant about this. I think my way is the best way. Follow my way. Do not do any other way. And if you do it any other way, I'm going to say, how come you didn't do it my way? Because I really feel it's the most efficient way. Here's how you should do it. And I'm going to show you some sloppy ways afterwards. Okay. And I feel weird because I don't like being, that's not who I am, but I have to tell you the way to do it. So anyway, here we go. You're going to multiply each fraction by the LCD, but you're going to just multiply it to the side of it, not top and bottom. Just put it to the side like this. And you'll see why in a moment, why this is the best way. Okay. So it's fair treatment because I'm doing to every fraction. Every fraction gets the same treatment. Now, let's focus on this. You have 4x times x plus 5 times 1 over x. For example, if I had 4 times 1/8, you could just cross cancel like that, right? Right? You would do that. Or if you have something like this here, you just cross cancel, you just get 1, right? You do the same exact thing. What can I cancel between what's blue and what's red? Exactly. And what are you stuck with? Okay, see how you eliminated the fractions? We busted the fractions right away. Now look over here. You have 3 over x plus 5, and what do you have to the right of it? 4x and x plus 5. What can you cross off here? What are you stuck with? 3 times 4x. Okay, now look on the right side. What do you see here? What can you cross off? 4. What are you stuck with?
X times X times.
We've immediately busted the fractions. You do this, it should be smooth sailing afterwards. If you don't do this, best of luck. Seriously, you really got to bust the fractions right away. So that's why I recommend it. Then at this point, you should know 4x plus 20, it's not hard. 12x, that's not hard. Then of course you get 3x squared plus 15x. Right, that should be pretty straightforward, right? And then I'll move everything to one side. But before I do that, let's combine like terms. So far, we're okay with what I'm doing. All's good, right? Okay. And this is in the calculate portion, by the way. So you should be able to use your plot form program afterwards when you're done. To check your work. Anyway, what should I do next?
Move it to the left.
Yeah, move everything to one side. I would probably move everything from left to right.
Why left to right?
So I can keep the leading term positive. So this is where the sloppiness comes into play. Some students will move this stuff to the left side and they'll have negative 3x squared. That's awfully hard to factor. I want to keep that 3x squared positive. So let's move the 16x to this side and the 20 to that side. And I'm going to be honest with you guys, it is going to be like pretty darn close to this problem. It's going to be a nasty factoring. But I have to do this. I have to, for your own benefit, as we go into pre-calculus, you have to be able to be comfortable with this. You guys know what to do here?
Yeah.
Multiply 3 and negative 20, get negative 60. And what do you put down below? Negative 1. What two numbers multiply to negative 60 and add to negative 1?
1 and negative 16.
Should be. Wait, hold on a sec. Did I do that correctly? I hope I did. Wait, shoot. Oh, wait one sec. I think I had to remove this problem. Okay. God damn it. Sorry, my fault. Damn. Hold on. Okay. Trust me, it will be factorable on the test. I worked it out. I'm sorry about that, guys. Okay, well, that's why it's not on the solution key, because now I understand why it's not there, because it probably didn't work out. Ah, man. This is not factorable. This is not factorable.
But the one that's on Friday will be back.
Yeah. Okay. Anyway, just trust me, it will be factorable. Let me make up one that will work. What if I did, what if I made that -4x? What if I did that? Okay. Okay, in this case, how would you factor it? So what would multiply -16 out to -4?
20.
How about -10 and 6? Right. So let's assume there's a -4 there. So my apologies. Sheesh. Didn't realize that happened. Okay, it's all good. So you get -10x and 6. And you guys remember what to do after that? That's 3x and x, -10 and 2. And so you have 3x minus 10 and x plus 2. And then, of course, you solve each case. You get 10/3 or -2. My apologies. I thought that would work out. Okay, anyway, but you'll see a problem. Trust me, I did work out last night. It does work out nice and clean. I didn't time myself, but it was fast. Okay. Okay, so we're cool with that?
Yeah.
All right, okay, good. Let's look at number 3 now.
Calculator on this one?
Yeah, you have to use a graph calculator for this one. So what you're going to want to do is isolate y here. That should be easy. Y over 2 equals -4x plus 5. Multiplied by 2. You get -8x plus 10. And then graph that as well. And just see where they touch. That's all. So let me pull up the graphing calculator so you guys see that in action. Math. Rapid EMU. Okay. And we'll play the game very shortly because I know we have to get to that. So hold on, I have this right in front of me. Okay, so -8x plus 10. -8x plus 10. And I'll share this recording once it's done. 6 1/3 raised to the x power. Okay, graph it. Okay, so you do want to be somewhat accurate with your graph. I mean, like -8x plus 10, what's your y-intercept? You guys should know that. 10, what's your slope? -8, so you should have something like this here. That's good enough, right? And then this right here is a exponential. If you plug in 0, you should get 6. If you plug in 1, you should get 2, I think. So it'll kind of look like this here.
You need like 3 specific points.
Yeah, I'll ask for that. Now, do you guys remember how to find the point of intersection? You hit second trace, you pick option 5, and you move close to the point of intersection. And hit enter 3 times. 1, 2, 3. And there's the first one, 1, 2.
Go back to your y.
Sure. Yep. That's what you should have.
And we can put the point of intersections as 3 other points.
Yeah, so definitely one solution will be x equals 1. Well, actually, you want to give the point the coordinates. I'm gonna you have an something here. I'll fix it real fast.
Yeah, that's not plot 1. Yeah, plot 1. Yeah, it's like some statistical thing.
Wait, what is like the box for?
Oh, just put your answer in. So 1, 2. And then I think there was a second point of intersection.
Yeah.
If you do it again, second trace option 5, just move close to it. Somewhere over here, I think. Yeah, -1, 8, 18. Which might be hard to show. The graph doesn't show that, but just plot the point. You'll be fine. I was kind of sloppy when I did this. Okay. So definitely you'll see that. Correct, right. remember I said number 2 is not there, but we already did 3, 4. Cross off 5. We're not doing problem like 5. Cross it off. We're not doing that. We already did 6. Okay. Cross off 8 as well. We're not doing that.
No, right.
Okay, last one I want to do 7 and number 7. It's the last one I want to do. Then we'll play the game. Okay, these are also review questions. These will be on the test. Okay, and I'll tell you right now, it's pretty darn close to these two. They're pretty darn close. Let's look at 7a. Okay, this is again. I'm going to say my way is the best way. And here's what you should not do. I'll see students like, oh, I want to expand that. Let's expand it. Let's make it more complicated. Let's do x squared minus 14x plus 49. And then all of a sudden you make some errors and then you're like, I don't know what I'm doing. I can't factor it. No, don't do it that way. What do you think I'm going to say you should do as your first step?
Move down.
Thank you. Subtract the 9, guys. What's the second step? Thank you. And put plus or minus 2. And lastly, what's your last step? There you go. So what's 7 plus 2? 7 minus 2? 5. I did that in like in 15 seconds. It's way better. I've seen some people really just go in circles here. We don't want circles. We want a linear path. Get straight to it, be done. That's the best way to do it. Don't let anyone tell you otherwise. If they say expand it, they're full of shit. Seriously, don't do it that way. Do it this way. Sorry for swearing. Okay. Does that make sense? We're cool with that? Okay.
B.
For B, this is a tricky one. Okay, I've seen some students do some really weird stuff with this as well. You're asked to get x by itself. How many times do you see x? Yeah, right. And it's a weird problem because you guys haven't really done enough work with this yet. Yes, there is one like this on a test. Okay. If you want, you could divide both sides by x. I've seen some students do that. Don't do this. Don't write this down. I've seen some students do some weird stuff like, oh, let's divide by x and let's get rid of that. Then I'll have 2 plus 3. And then they'll do something like this here. And then they get really confused. They don't know what's going on. That's all bad stuff what I just did. What I did was actually horrible because it's not fun to order operations. Or I'll see some students like, I don't know, they'll do this. And then they'll divide the 2. But have I really isolated x?
No.
No. I wouldn't. If you did this, I'll give you some points because at least you're doing things correct. But you didn't meet the objective, right? At least you did things algebraically correct. You just didn't finish off the problem. And then it gets more complicated, right? Because you create fractions. Here's what you should do. Always, always, always collect all terms with x on one side. What does that mean? That means move the xy to the left side, move the 3 to the other side. See how I just did that? I moved the xy from right to left, the 3 from left to right. So what does the right side become?
2.
Okay, what do you think? This is the key step. This is the part a lot of people miss. And I literally had to retest this 3 times last year. Even I told them, do it this way. And I don't know why they didn't do it this way. What should be my step? Next step here, right next to the star. What do I do about the x?
Combine.
Not combine, opposite of combining.
Add.
Okay, you have this. Go ahead, say it. Thank you, Eloise. Awesome. Factor out, guys. Factor. I can't say it any more times. You got to factor out. Now you're one step away. X is being multiplied to that chunk. What's the opposite multiplication?
Division.
So divide it. Done. Why do we care about this? Because ultimately, most of you guys are going to be moving on to calculus. Next, you do pre-calculus. Year after you calculus. You got to be comfortable with this. You can't be in calculus and struggling with this because then you can't even do the calculus stuff, right? Very important. You have to be comfortable with isolating variables. It's a skill that has to be second nature after a year and a half from now. So, because I've taught calculus and I've had students struggle. It's like, great. It was pandemic, whatever. It's like, I had to deal with it. But yeah, x equals 2 over 2 minus y. And leave it alone. That's what you got to do. Okay. So I feel better that we did this. Okay. We're going to, we have a half hour. So actually, this is perfect. This is exactly what I wanted. Okay. So for the Jeopardy game, here's how it's going to work. I'll pull it up. I'll stop recording.